It's turn. The moon. Tell us about the moon. Is it loading? The moon has. Devin, read for us.
Oh, I was reading it in my head.
No, we're waiting for you.
The moon has nearly a circular orbit around the Earth with a radius of 33,800.
More. 380,000.
380,000 in a period of 27.5 days. What is the moon?
Centripetal acceleration. So just like this pen and this clipboard, the moon spins around the Earth, right? The moon spins around. Who knows why the moon spins around the Earth? Yeah, what's the gravitational pull? Good. And the gravitational pull has a speed. The moon tries to get away, but the Earth pulls it back in. But then the Earth doesn't make the moon crash into the Earth, right? The Earth just keeps making the moon swing around, just like the pen and a ball on a string. So this physics problem is asking, how fast is the moon getting pulled back in? Before we do that, we have to turn this into a small number, because I don't want you to write this 5 times over and over, because sometimes we forget to write 0, or sometimes our 0 looks like a 6 because we wrote so fast, or maybe you add an extra 0. So if you work with a smaller number, you're less likely to make mistakes. So this is how you make smaller numbers. Write 380,000 in your paper, just like Devin read. See, look how my 0 looks like a 6. If I'm doing a ton of math, like we always do, I could accidentally make it into a 6. So let's make it into a small number. Write that down in the first step. We're going to write down 380,000 on your paper and shrink it to just 3 numbers so that we don't have to rewrite, make mistakes, so we can put it in our calculator, make our lives easier, and even your paper saves space. Are any tutors ready for helping? Okay, please do your work, and then you can help us out. How do we make this into a smaller number? Well, if there's a decimal right here, right, we didn't change the number. But if we shift it to the left, like this, does that change the number, Elijah? If we move the decimal from here, it does, right? Now it's how big? 38,000. So I'm going to keep moving this until the decimal is in between the 3 and the 8. Try that again. Didn't save. So it's going to be 3.8. Now, did I make this number different than this number on top? I did, right? When I do this, I have to multiply it by an exponent, so they're still the same number. So how many exponents do I multiply it by? Caleb, how many times did the decimal move? 1, 2, 3, 4, 5. So the decimal moves 5 times, which means we multiply it by an exponent of 5. So times 10 to the 5. Okay? Now they are the same number. 3.8 times 10 to the 5 is the same thing as 380,000. You managed to wrote it down? Okay, good. So how do we make this into a smaller number? Because it still looks like a lot of work. You still got to write times 10, you still have to write 5. So we did this in the previous physics problem. We did 3.8 raised to the 5th equals 3.8 E5. All right? this is the same thing as that, and this is the same thing as that. They're all the same thing. But this is so much easier to write, especially if you do that in a little fraction or you have to do that in a little calculation. So that's the first step. Make your huge number into a small number. The second step is to solve the problem. We want to find how fast is the moon coming back to Earth before it tries to get away again. Well, this triangle will help us find that. Acceleration equals velocity squared over r. Find v, because we need v to find a. So third step will help us find v. We get the radius, we get the time, and then we divide it out, and then we plug it in. So we are on Caleb's turn. Caleb, what is the radius? 1,000, but we shrank it to a good 3.8, but say the whole thing. Even shorter, 3.8. What's even shorter than that? E5. All right. Now, next to this is a fraction that turns kilometers into meters because velocity is only meters per second. Exactly. So let's do that. So in this last part on the third step, right, 3.8 E5 times 1,000. Jimenez, you're up. Put that in your calculator. 3.8. How do you do E? Click second, x minus 1, 5. And then you can right away click times 1,000. What do you get, Jimenez? Say the whole thing. To the 0.8. Times 10 is the same thing as E. 8. That's it. That's all we had to do. Now this goes in here. Are we doing math? Ashley's name is not in the packet, right? Please do some math. I need you as a tutor, Caitlin. Okay? And your grade is dropping. So being a tutor gives you full credit on the test, right? You get to help somebody. Aaliyah, I put you over there so you can be helped, not talk about Ashley. Okay? Yes? Thank you. Okay, we found velocity, right, Devin? Now we're going to find time. So, Devin's turn. What's our number of days in our problem? What is it? Okay, let me get his answer and then I'll help you. Just look at the problem. Where does it say days? No, in the problem. These are blanks. We're going to fill in the blanks. I need you to tell me the days in the problem. It's a period of 27.5 days. That's all you had to do.
I thought you were talking about, like, remember you said, I forgot what it's called, where the moon orbits around the Earth.
Yeah.
A certain amount of time.
No, a certain amount of speed. It comes to the Earth, a certain amount of speed. Okay, what's your question? No, this is your static friction coefficient. Here it says, up there. In the notes, this problem says static friction is 0.6. So your A will be different. Okay, so Devin gave us the days. Now Devin put in 27.5 times 86,000. Why? Because there's 86,400 seconds in a day. Velocity cannot be in days. It has to be seconds.
27.5 days.
86,000. 86,400. Close. You rounded too early. 2.338. And there's a little exponent on the right that makes a huge difference. E what? E5.
Oh, this?
Yeah. What is it?
It's 10. It's 10. Times 10 and then it's 0.6.
Yes, to the 6th. So, just 6. It does look like 0.6. But it is 6. 2.38 E6. That is how many seconds it takes for the moon to go around the Earth one time. Okay? So that is our time. Now we're going to put it into our velocity so we can find acceleration.
Wait, so.
Yeah.
I never noticed that, like, the 6 on the calculator.
Yeah. Yeah, that little 6 means 6 zeros come after the number. So this is like 2 million seconds. But we got to shrink it down to this. And then we're going to take this and put it down here and save up a lot of space. We don't have to write 2 million seconds. We can just write 2.38 E6.
So the times 10, it doesn't matter?
The times 10 is E.
Oh.
That's the same thing. They're equivalent. Okay, let's find velocity. So Elijah, this is the formula for velocity. We're going to take 2 pi r divided by t. What's r? R is radius. 3.8, say the whole thing? E. Where'd you get 5? Look at our third step. R. Oh, I see. So it is E5 in kilometers. It is E5 in kilometers. But velocity can't be in kilometers. It has to be meters per second. So we have to turn it into meters. So 8. I think it would have helped to put a little m here. So it's meters. Caleb, you have a question? Of course. Thank you for waiting. So 3.8 E8. And then our time, Elijah? Our time is up here. What's our? Yeah. Well, you're 27.5 days, but we turned it into seconds. So I'm learning right now that when I do this with period 4, I got to make sure I put my units here so we know this is the radius and this is the time. So what goes down here? 2.38 E6. Caleb, you're going to put that in the calculator all in one step. So click 2 times, and then click pi, which is on the left. It's like the 4th button from the top corner. And then times again, 3.8, hit second, x minus 1. Second, and the x minus 1 is right above 7. And then click 8. Then click divide. 2.38. Second, x minus 1, 6. These are huge numbers. This is almost in the billions. That's in the millions. Hit equal. What do you get? Tell me. Read it to me. 1.003197654. And then what's after that? Times 10 to the 03. That's correct. That's correct. You found how fast the moon is moving. So, everyone put 1.00 E3. So Caleb did this in the calculator. We don't have to put anything here. Almost done. Jimenez, how fast is the moon coming at us now that we see how fast the moon is going around? Plug in V2 and R for this bottom step. What's our V2? Or what's our V? Caleb just found it.
Are we on the 6th step yet?
We're on the 6th step now.
Wait, so are we not putting nothing in like blank line?
Yeah, he put it all in the calculator in one step. So I guess you can just say in calculator. 1. Yeah, the answer for velocity is 1.00 e to the third. This can all be done in one step. And then the sixth step is taking the fifth step answer and the fourth step answer and dividing out. So Jimenez, what is our fifth step answer? You just have to say it out loud. What is it? 1.00 e to the what? We're trying to do the sixth step. This is supposed to be V2, and that's supposed to be R. Did you know it was 3? 1.00 E3. This came from here. This is our V. V is this. So now we just need R. What's R, Jimenez, in our steps? Fourth answer is, I should have said third step. Because fourth step is T. There's no T here. We're going to use third step. Thank you for listening. So, what's our R? You see R? No, just tell me what to write. 8, good. 3.8 E8. All right, put in your calculator, everyone. 1.00 hit second, x minus 1. 3 hit squared right away. Hit divide. 3.8 second, x minus 1, 8. I know it's a lot, but it'll all make sense when you remember E is second, x minus 1. And we have a whole nother physics problem to get used to it. So what do you get when you hit equals? 3, but there's stuff on the right. What's on the very, very right of your calculator? You have a 6? Let's see what your E is. 8. I got -3 on the right. Did you guys try it?
I got -3.
Wonder. It's the same. Oh, you didn't square it. You gotta square it. So Kayla got -3. Devin, did you try it? Okay, try it. Go 1.00 second x minus 1 3. Yeah, second, and the x minus 1's right above 7. Great. So that's what you have to do. So 1.00 e second x minus 1 3, and then hit square right away. And then divide. Okay, I'll repeat it. I'll repeat it. So this is the time to get it right.
I did 1.00 and I got the E.
No, okay, good. You got the E. Go ahead. Yeah. And then it's 3, and then you're gonna hit square, which is next to 7, and then divide by 3.8 second x minus 1 8. X minus 1 is right above 7. The x minus 1 button is above 7. And then you have an E now, right? And then 8. And then hit equals. Okay, so we'll try it again. The square root. No, it's a regular square. You hit this.
Oh,
You just typed 2, and then that was not.
I did the arrow.
Square. There you go. No, 3 square. There. Divide by. And don't hit equals. Let's see what you get. 3.8. Hit 8. And then second, x minus 1. Second, x minus 1. And then 8. And then equals. There, you did it. See? So 6, 3, and then negative 3. Good. So if there's ever a negative after the e, that means it's a smaller number. Like this decimal is actually going to be like right here. So it's going to be 0.00263 meters per second. The moon comes at us very slowly, which is good. We don't want the moon to hit us. The moon comes at us very slowly because of gravity, but then the moon is so heavy, it tries to get away again. But then our gravity pulls it back a little bit. And then it tries to get away again. So you know stop signs have those straight edges, it goes around? The moon actually is doing that, but at very, very short distances. So it looks like it's just going in a big circle. All right, that's the physics. Okay, you guys need like a little 3-minute break? Okay, take like a 3-minute break, and then we're going to do the hardest physics problem we've ever done yet to this day. All right, so take a nice little break. Yeah, yesterday is that one. Yeah, that one has 2 levels of conceptualization. Take a break. Go on your phones. Kayla, are you finished with practice problems? Okay. And how did that go? Yeah. So you found friction force. Good. Plug in that. Mass. And it was student 3. Okay, let's take a look. So this is the 1,000. Why would we use the same? How about the one above? Oh, like they're not exact, right?
Yeah.
They're just close. So 225. Okay, so that's the last one. 2 kilometers is 14. Okay, so these are the same. This is just the next one. Right? And then your acceleration is 0.47. Yeah, those are different. The force is your grams times velocity squared. So where's force here? So force is not provided here. Here, the frictional force. See my notes. Inverted. And here, force squared. Force. Plug in. Friction times mass. Gravity. Big number. So this is how fast the car needs to be pulled inward. And this is greater than that, so the car will stay on the road. This number is less, so it will not stay on the road. So you did it right. Not sure what happened here. Right, payment 162. Okay, so ignore that. Well, this one is here. Yeah, it is. This is decimal. Time, thank you. We're doing practice problems. Oh, I just plugged in for block. They didn't find. Okay, so I see what's tough is that your answers are already inside his or her dimension analysis. Where's this? Okay, all right. So my number 10s are off. Follow your here. Force 0, 3. Force. Okay, I'm going to keep this. For a circle, oh, okay, for this, oh, you want number 3 or number 1? Number 2, you multiply 2 by 7. You get a final number. All right, fellas, we have 20 minutes before, in my opinion, I want you to just work on your own after like 10 o'clock, after 10:07. Because right now it's 9:37. This next problem is going to take about 20 minutes. But we can do it. Wipes? Yeah. But this is an open path right here. Yeah. Okay, so let's close the second page. Go to your third page. Oh, I should have stopped the recording.